So, welcome back to chapter number 2. So, we are going to start from the next topic where we left, and it is acceleration. Acceleration is the rate at which velocity changes over time. So, you see, average acceleration is equal to change in velocity over change in time interval. Change in velocity over time interval. So you see, before you did velocity is equal to del x over del t, displacement over time. Now you have change in velocity over time interval, which is average acceleration. So change in velocity mean, of course, you have two velocities. That's why you can find out change at the difference. Vf minus Vi divided by final time minus initial. Okay, so you are driving your car, for example, at any time initial t sub I, velocity is v sub I for initial. Sometimes you may find v0 or v0 initial, and at time final velocity becomes vf. So this is the average acceleration. You see, the unit for it is meter per second square. Why? Because on the top you have delta v, change in velocity. So velocity is in meter per second over time. Again, time unit is second, so you get meter per second square. So when an object accelerates, it means its speed is increasing or its direction is changing. I mean, if speed is changing or direction is changing or both change. And like velocity, acceleration is also a vector quantity. All right. Now, we are going to do this example, which is on page 35. A baseball player moves in a straight line on the ground, of course, in order to catch a fly ball hit to the outfield. So a ball is hit in the outfield, and the baseball player is going to catch that, and he's running with different velocity at different time. So his velocity as a function of time is shown in the graph. You see, along y-axis you have velocity, and along x-axis you have time in second. So when you keep on taking the reading for velocity of the baseball player at different times, you get different points, and when you connect the points you get a graph like this one. First a line going up, then horizontal line, and then downward line. So you have to find out instantaneous acceleration at different points. First of all, at a point, you see, we have done before in case of velocity that when you have position versus time graph, or even right now, so you have a straight line like this one, for example. First of all, you have to find the slope of this line taking any 2 points. I like to take final point and initial point, but you can take any 2 points, by the way. The slope for this is from time 0 second up to, if you go up, this is 2 seconds. So from 0 to 2 seconds you'll get the same slope for the this line, and that will give you the average acceleration. And average acceleration mean you will be having this instantaneous acceleration if you take at half second, 1.5, all the way from 0, in between 0 to 2 seconds, you will have the same instantaneous acceleration. So we are going to find first of all at a point. So it means instantaneous acceleration is equal to average acceleration, which is the slope of this line, mean delta v over delta t. So you have to find out final minus initial velocity over final velocity minus initial. So you start from 0, you go all the way up to this point, which is at 4 meter per second velocity. As I told you, you can take any 2 points. You can take this point and this point. You can take this point and this point, but I'm taking max far away points, starting and ending. Okay, this point and starting 0 point. So final is this point. So if you go on the left, this is 4, right, minus initial, which is 0, over time, 2 final time, 0 initial. So you get how much? 2, mean this is plus 2. So when you're going up, so slope is positive. So instantaneous acceleration or the average acceleration are the same for a straight line. Okay, that is first part. Now if you do at B, so you will be doing the same thing. A instantaneous is equal to average acceleration, which is the slope of course, and we use the same rules. I'm not writing the rule here directly, I'm doing it. You see, this is horizontal line, and the slope of the horizontal line is always 0. Why? Because if I take this point, final, go left, this is 4. Initial point, again go left, this is 4. So 4 minus 4 divided by, what about the time? 3 minus 2. So 3 minus 2. So instantaneous acceleration is 0 for B. So that was for the B. So this was for A. Now I'm going for C. At C point, again instant. C mean at this point, but it doesn't mean you take exactly at this point, because at this point, this point, this point, slope will be the same from time 3 second to 4 second for this line. So I take initial point, this one for C part, and this is the final point. Now this is final, you go left, what is this? 2. So slope this is final, again this is final, go left, this is 2, minus initial for the third line, this is initial starting point, which is 4. So 2 minus 4 over time, final time 4, initial time 3. This is minus 2 meter per second square. You see, this is coming down, so slope is negative, mean acceleration is negative. Now you see, we are going to do you see, whenever you're going to play something, you have to set some rules, some regulations. So similarly, we are going to solve motion of different objects, so we have to have some formulas from some equations, right? So we have these 3 equations of motion we'll be using frequently in solving. So this is equation number 1, this is number 2, and this is number 3. Now you see what is Vf. As you know, Vf is Vi is the initial velocity. Okay, okay, Vf is the final velocity, and you know, similarly you have A is equal to acceleration, which is average acceleration, of course, and delta x, or x is the displacement. Okay, and t, or delta t, is the time interval. Okay, so these are the things. Sometimes you need, you see, we have done average velocity, that it is equal to uh, Vf minus Vi over Tf minus Ti, which is the change in uh, x, change in displacement over time interval. Also we have another rule. You see, sometimes how to find the average. For example, you have two quizzes. In one quiz you have 5 marks, in second quiz you have 4 marks. How to find out the average? Add both 5 plus 4 divided by 2. This is how we find out the average. Similarly, to find the average velocity, you have two velocities. You have final velocity, you have initial, two velocities, so divided by 2. Sometimes you need to find out average velocity with this one also. This one we already finished. So we'll be using frequently these three equations of motions to find the motion problems of different objects. Let's apply these three equations. Now there is one question. Which equation to be used which time? So you will learn this with the passage of time and with a lot of practice. And once you have question like this one, you have to write the given information first very clearly, and what is known, what is unknown, and then you will decide. And it's good to write on the sideways all three equations, or then you look at your information in the question, and then you will decide which equation. Okay, now a race car starting from rest mean, it's clear, initial velocity 0 starting from rest. If some object ends at rest, so final will be 0. In this case, initial is 0 at a constant rate of 5 meter per second square. So this is your acceleration. What is the velocity of the car after? So initial we have Vi. So what is the velocity after it has traveled 30.5 meter displacement? So this is delta x, and final velocity you have to find out Vf. Okay, so we have, you know, Vf you have to find out here. So we have this equation, Vf square is equal to Vi square plus 2a del x. In some books you may find V0 or V naught, initial velocity. Some books you find V sub I for initial. Okay, and Vf for final, or simply V for final. So I'm using Vi and Vf. Okay, so Vf you have to find out. Vi is 0, okay, plus 2a is 5, delta x is 30.5. So you get, VF square. You use a calculator, you will find out 305. This will give you, if you take the square root now, VF square is equal to 305. You take square root, under the root both sides. This will become VF, and you get how much? 17.5 meter per second. That's it. Now B part, how much time has elapsed? So now you have to find out the time you take from this point up to the final point. So we have this equation, okay. VF you just finished 17.5, 0, like this one. So you get 5t is equal to 17.5 divided by 5 both sides. So you get t is equal to how much? 3.50. Yes. C part, calculate the average velocity with two different rules. You remember I wrote these two different rules. One rule this one, the second rule this one. So I'll be using these two rules. So average velocity is equal to del x over del t. One method this one, and the second method Vf plus Vi whole divided by 2. So this one you get V average delta x. You have final minus initial. You see final velocity 17.5, initial 0, divided by time interval is we just finished this time interval 3.50, initial 0. So you get with this rule 8.71 meter per second. With the second rule, you have final 17.5 plus initial 0 over 2. So you get 8.75, which are very close to each other, okay, meter per second here. Alright, so this is meter per second. That's it. Then we are going to discuss, you see, up to now, up to here, we discussed the motion along a single line, of course, but along the x-axis. Now, what happens if you have motion along y-axis? The object is going up or falling down. Now, free fall motion of an object when you have only one force acting on the object due to gravity. Why? Because at your level we assume that there is no force of friction and no other horizontal force. So only force is, keep in mind, the force due to gravity. So the acceleration on an object in free fall is called the acceleration due to gravity. We call it free fall acceleration. Right. So we call it a acceleration along y-axis is g due to gravity. Now keep in mind that if you remember that in case of motion along x-axis, you observe that the acceleration may be some number positive, maybe some number negative, and it may be 0 along x-axis. But good news is that you don't need to calculate acceleration again and again along y-axis. Its acceleration due to gravity is a number 9.8 meter per second square, and we use negative sign with it due to the fact that Earth attracts all objects towards its center. Alright, now it means that whether the object is moving up, whether it is on the top or it is going down, in all cases you see here this case moving up, acceleration 9.8 with negative sign. It is on the top, again 9.8 but negative again. Here again when you are coming down, minus. So don't be confused yourself that when it is moving up it's positive. No, the acceleration is always negative 9.8. Why? Because Earth attracts every object towards its center along negative y-axis. Okay. Now we have equations of motion. You remember we did equations of motion for x-axis, right? That was first equation was final velocity. The second equation VIT plus half AT square. The third one was VF square, final square is equal to, right? That was along x-axis motion. Okay. Now we are talking about the vertical motion or y-axis motion. What we do, you see, when you are along x-axis, positive or negative, okay, you are using displacement x. Now once you are traveling y-axis positive or negative, we simply replace, we are using the same equation for vertical, for y-axis motion, but with a little change. What are the changes? Instead of x we use y, and instead of acceleration a we use g but with negative sign. Now the first equation for vertical or the y-axis motion will be this one. Change it. Vf is equal to Vi plus At. Instead of plus A we use minus Gt. This is first equation. Now second equation, delta x, we have delta y. Vit Vi t minus half g t square. You see this is half a t square. Half and t square the same, but instead of this a we are replacing minus g here, you see. And the third equation we'll be using this one, vf square minus 2g del y, delta x replaced by delta y, and a is replaced by minus g. So these are the three equations we'll be using frequently. So we are going to do the last example, 2.8. Right, a ball is thrown from the top. So you are standing here, you have ball in your hand, and you throw it up. It goes up higher and higher and higher. You throw it with initial velocity vi, which is 20 meter per second. Once it is going up, velocity is decreasing. When you reach on the top, final velocity becomes 0, and then you start coming back. You reach the same point where you started, and then you go down and up to the ground. So you have different parts of the equation. So a part, determine the time needed for the ball to reach the maximum height. This is maximum height from here up to here. This is maximum height. So you have to find out the time. Okay. Now we have first equation of motion. GT. Final velocity becomes 0. Initial is 20 minus 9.8 t. If I take 9.8 t negative on the other side, it will become positive. I divide throughout by 9.8, so you get t is equal to, so you get the time 2.04 seconds. That's it. Then you have to find out the maximum height from here up to here. This is the y max. Now I use this equation, okay, VIT minus half GT square. So y max unit VI20 T 2.04 minus half 9.8 T. So you get finally y max you get 20.4. That's it. Then C part. Find the time the ball takes to return to its initial position. It's interesting. You see, you start from here, okay? You are going up. Height is increasing. Once you come back, height is decreasing. Once you reach at the same point, what is the height? Height is 0. Keep in mind. Okay? So height is 0 when it reaches at the same point. So we are going to do this C part. Okay, so we are using the same equation. gt square. Okay, as I told you, y becomes 0. Okay, initial is 20, time you have to find out minus half 9.8 t square. Okay, now I'm going to write it. 0 is equal to 20 minus, I divide it, so you will get 4.9. Can I write like this? Yes. What I am doing, I am dividing throughout by t. I divide 20t by t will cancel, only 20. And this is t squared divided by t, I will get only 1t. Here 0 by t, it will get 0. Alright. Now, I take this minus 4.9t on the other side, it will become positive. Divide by 4.9 throughout, so I get okay 4.08 second. This is one method of finding the time, but there is another method which is very easy method, and as we discussed in the beginning that the motion along the y-axis, you have only a single force, which is gravity. Okay, why? Because we assume that there is no other force, no x-axis, for no force of friction. So if it is so, then we assume that when you throw the ball from here up to this height, it took 2.04 seconds. This is what we discussed previously here. So when we assume that there is no other force, so it will take the same time while coming down. Okay, you are coming down, you will take the same time. So we can double the time. So the time will be equal to 2 times the initial time from here up to here. We simply multiply by 2.04. So it becomes 4.08 seconds. So this time and this time you get the same time, but different rules. But in the exam you need only single method. D part, then the time needed for the ball to reach the ground. Now you are here, you started from here, you went up, come back here. Now from here, the time needed for the ball to reach the ground. Okay, so we use right, sorry, you need velocity also in this C part, and the velocity also. So we need velocity final, sorry, Vi minus gt. All right, so at this time, what will be the final velocity? So velocity initial is 20 minus 9.8 multiplied by 4.08. So final velocity you would get minus 20 meter per second. Now let's go to D part. Okay, the time needed. So I use this equation, as I told you, with the passage of time, with practice you will come to know which equation to be used. VIT minus half GT square. Now VI is 20, time unit minus half 9.8 T square. I take this, you see, from here Up to here it is given to you 50 meter, and I take minus because you are coming down along negative y-axis. Okay, so I take all these things on the left side. This will be 9.8 divided by 2, 4.9. I take all to the left side. Negative, this will become positive. 4.9 t square minus 20t minus 50 is equal to 0. You see, you have this equation like this one: ax square plus bx plus c equal 0. And this is the quadratic equation, and you have to find out unknown. In this equation, x is unknown, we have t unknown, and a you have this, b you have minus 20, c you have minus 50. So t will be equal to minus b plus minus b square minus, sorry, b square right. So b square minus 4ac whole divided by 2a. 2a, I told you 4.9, minus b how much? Minus 20, plus minus b square minus 4a. Okay, 4ac, see how much? Minus 50. So you get the two values will be getting plus and minus, and we would take only plus time because time is always increasing. We cannot take time minus. If we take minus, mean we are going in the past. Yes, the scientists are still working on this crazy idea to devise a time machine where they would use that machine to travel to the past. So I would really like, if I'm still waiting, I'm also waiting for this time machine. So I'll be happy if I sit in that time machine and I go to my childhood. Allah, it will be nice. Uh, what the children are doing? Nothing. Eating, playing, and sleeping. No work, no study. Okay. Yes, so this is the time. Now the last part of the question, E part. Find the velocity. Velocity means final velocity, of course. And the position. Of course, we're talking about the y position or the y displacement at time 5 seconds. Okay. So we have these two equations. We have Vf is equal to Vi minus Gt. Okay, Vi we have 20 minus 9.8 times 5. So you would get, after 5 seconds, the velocity final will be 29, mean minus, okay, it means it is going to the downward. And the second one, we need position, so y is equal to minus gt squared, 20 t 5 second minus half 9.85 square. Okay, so once you use your calculator, you would get minus 22.5 meter. So it means at time 5 second, the object is going down in the minus direction. So this is the velocity final, and position during the vertical motion, it will be 22.5, but going negative on the downward direction, so negative. Okay, so that was the last the question